Yes, sir. Good evening, sir.
Yeah, good evening. Okay, am I audible now?
Yes,
Hello.
sir. Yes, sir.
Okay. Oh, we'll wait for 2-3 minutes and let everyone join. Then we can start. Right? Yeah. Hello, everyone. Good evening. Am I audible?
Good evening, sir.
Okay. So today we are going to start the basic comparison. I will told you to explore the OpenCV library or now we can implement automation and all the things you guys done any research or anything in that. Have you gone through OpenCV documentation or anything? Anyone?
Yes, sir.
So, like, do you have any question or anything that you can unmute yourself and ask before starting the computer vision basics.
Sir, I wanted to ask, how can I install in a virtual environment? Like I saw you have to download a repository, like
Okay, so like what you want to download in virtual environment?
the OpenCV library.
Okay, so what you have to do is you have to first create the virtual environment, and you have to
Hmm.
activate that virtual environment. Then you can download the OpenCV library that
So
you are
like
down.
directly installing the repository in the Venv file.
No, you don't have to download the repository. You just need to run the command like pip install OpenCV.
Okay, the documentation didn't mention it. I'll
Okay,
check it out.
okay. So yeah, you just need to run that command that pip install OpenCV, and that will install the OpenCV.
All right.
Yeah. Anyone? Okay. So in today's lecture, what we are going to do is we are going to start with the basics of computer vision. Wait for a minute. I will share my screen and we can start. Okay. So my screen is visible to all of you. Okay. Okay. Right. So we have gone through this like what is computer vision, why we can use that, and all that thing. So basically, we use computer vision to process the visual data, like the data that are not in the textual format and all that thing. So for the data and video analysis, so we can like we are using this computer vision. We have also seen the application of like computer vision for traffic management. So yeah, that we are done with. We are going to start with the basic principle of image processing. In today's lecture, we are going to see how we can process image, how we can read the image, and how we can convert this into grayscale or RGB image, how we can blur image, how we can write text on the images, and all that thing that we are going to cover in this lecture, right? So so basically, we can represent image in the two things. One is grayscale images, and the second one is color images. That is the RGB channels. So I write a sample code that I'm going to share with you by the end of this session. So please concentrate in this code. I'm going to run this code at this point of time, and after completing this session, I'm going to share with you. I will share. I will share this notebook with you, and you can run it your own PC. And if you have any like error or doubts, you can ask in next lecture, right? So what we are doing is we are importing the computer vision library, that is CV2, NumPy for numerical processing, and Matplotlib for showing the images, right? So what we are going to do is we are going to read. We are having one IM read functions in OpenCV. The CV2 is nothing but the OpenCV library that we have downloaded. So what we are going to do is I have one image in my folder. Wait for a minute. Yeah. So this is the image that I have. So what we are going to do is we are going to read this image using OpenCV library, and then we are going to try to like use different techniques and methods, or we can say operation on this image, and we are going to see how the OpenCV library will help us with processing this image, or anything that we want to do with the image processing. So firstly, what we are going to do is we are going to read this image in grayscale. Like grayscale means the black and white image that I have seen. So we are going to run that thing. So what I am going is I am currently reading the image. Like the image has been read from its location. Then I am going to show this image. This zero means we are reading the image in grayscale. If you want to read it in RGB channel, then what we are going to do is we will write it as this cv2 dot I am read color. So that is going to read the image in RGB format, and we can see the colored image that we are going to see in later. So what I've done is I am read the image and see. This is the image that we have read. So basically it is a grayscale image. You can see here there is a value of x and y in the bottom left corner. So the x and y is whenever I am like my arrow is here, so the x and y are showing the coordinates of the image, like my arrow is going here, then x and y are showing like it is at 63 pixel on the x axis, and on the y axis it is the 61 pixel, and we have L, that is the value of that pixel. So in grayscale, what we are having is we are having the value from 0 to 255. 0 means like the darker, and like 0 means the black color, and 255 means white color. So see here we have white color. So the pixel value is 252, and at this point of time we are having the black color here. So see the value of L, that is gone down to 10 or 18 something. So that's how the grayscale image is has been represented. So wait for a minute, I will show you the numerical representation of this image. Wait for a minute. So yeah. So what I've done is I've created a numpy array of the images that we have read here. I've created a numpy array of that image, and I am going to print this array. I'm going to save this. So yeah. So this is the numpy array, like you can see. We are having the numpy array of the image that is containing the values of that pixel. So that we have seen 252, and this is the color of white, and when how we are done going down and down, that is going to be black color. That's how the image has been represented in grayscale numerical format. We are having a two-dimensional array that is containing the values of all the pixel x and y, and we have stored the values from 0 to 255. That's how we can represent the grayscale image, and this is how we can also represent using matplotlib. If you want to like showcase in graph or anything, you can run this. Okay, so yeah, see, we are having values from 0 to 255, around 255. 255 is white and 0 is going to be black. So wherever you are going, if that color is black, the value of that pixel should lies below 50 or around 0, and if the color is white, then that is going to be about 200 or around 250. That's how the grayscale is like grayscale images has been represented in computer vision. So anyone has any doubt in this, you can unmute yourself and ask. Anyone want to ask anything? Have you understand what I have done, or like you don't understand anything like what I have done?
Yes, I understood.
Understood, everyone? See, these are the basics that we have to understand clearly to go ahead with this project, right? We are going to like get in this code. What I'm doing is I'm reading just the image. So going ahead, what you have to do is you have to take the video. You have to extract all the images. Video is nothing but video is containing multiple images in a frame. So what you have to do is you have to read all the videos one by one that is given in the video. You have to read all the images, and you have to process like for object detection. What you have to do is you have to convert that images into grayscale, and then you have to use the object detection model to detect the objects on that images. So yeah, this is for RGB. I am going to share this code with you by the end of the lecture, so don't worry about that. You can try yourself at home. So yeah, now we are going to read it in RGB format. So in RGB format, the thing is different. So we are having a three-dimensional array that is containing one R is for red, G means green, and B means blue. So we are going to read all the dimension of the image, and then we are going to print that thing. So wait for a minute. Yeah, this is for RGB. Yeah, see. Now we are getting the colored images. Here in bottom left corner, you can see the value of X and Y. So X and Y are for the placing of that pixel. You know about that. That are the same as the grayscale image. But the thing is different is we are having RGB colors in this. You can see here R for red, green for blue, and B for blue, green for R, G for green. So as we ahead, this is the color combination. Like for yellow, the values of the R is 249, green is 243, and blue is 193. That's how the colors are represented in RGB format. So that's how we are going to read the image, whole image in RGB format. Yes, so continue. So the thing is like if you have to convert in grayscale conversion, we have seen with the grayscale conversion and the color images, how we can read the images in RGB channel and we can represent that images and all that thing. So going ahead, what we are going to do is we are going to see this blurring, how we can blur the image. If there are some parts that you don't want to showcase, so what you can do is you can give the coordinates of that part, and you can pass the value how much you want to blur that images. So what I've done is in this code I have read the images, I have read the image in color format, and then what I have done is computer vision library has a function called blur through which we can blur the images. So I have passed the image to the blur function, and these are the values of coordinate like wait for a minute, I will show you. You can understand what I wanted to say. See, this image has been blurred, but it is vertically blurred. You can see that thing. This image is vertically blurred. What if I wanted to do it in a horizontal blur? Then what I'm going to see do is I will reduce this value to 5 and going to increase the x coordinate to 50. Then what this thing is going to do is it is going to blur the images in a vertical direction, horizontal direction. See, now the image is blurred in horizontal format. So you can increase the value of these things. How you want to blur the images, like I've done is 10 and 10. What that thing is going to do is that is going to blur this image evenly. You are not going to see like horizontal blur or vertical blur in this thing. So that's how we use this blur function to, like, if you want to blur any part of this image, then you can pass the value how much do you want to blur, and going ahead what we are going to see is like if I wanted to blur, like wait for a minute, if I want to, okay, so if I want to blur the number plate of this car, then what I'm going to do is I'm going to use the blur function. I'm going to pass the coordinates we are having x and y coordinates. We are going to pass these coordinates, and the OpenCV library is going to blur that part only, like from here to here only. We are going to pass the coordinates, both coordinates. So this corner we are having x is equal to 124 and y is equal to 435. So we are going to pass this value pair, and at the bottom right corner, the value are 214 and 451. So we are going to pass this both value with the blur that we want, the pair of x and y. We are going to pass both of these thing into the blur function, and Yeah, OpenCV library is going to handle everything for us. Like it is going to blur that part of image and return us the blurred image, the like blurred part of this image. So now the thing is, we are having these images in
So
our
where do
projects.
we pass that?
What? Okay, so
Where
that
do we
thing,
pass?
yeah, okay, that thing has been passed in this. So see, I'm going to show you in the documentation. So see, this is the size that we are going to pass. We have to pass the image. We have to pass the size that we want to blur. And going ahead, we can pass the border that if we don't want to wait for a minute. If we don't want to blur the borders of this image, then what we are going to do is we are going to pass this to the blur function. So we have to explore the documentation of OpenCV blur function. There are multiple options that are available that you can use to blur like differently. You have to, like, if you want to blur the right corner, bottom right corner, then you can pass the value of that coordinates accordingly, that OpenCV is going to blur that image. So now what we are having is, we are having this image in our traffic management system. We are having one use case that we have to, like, detect this car, and we have to write that it is car, and we have also have to write the number that is there in number plate, that we also have to write in this image. So if we want to write anything in image, then what, the OpenCV library has one function, that I am read, that is going to read the image, then put text. There is one function that is put text, that is going to write the text on the images. So for put text function, what we have to pass is we have to pass the image that we have read using the I am read function. I have read the images, like image.jpg that we have in RGB format. We have to pass that thing here in the put text function. I want to write that it is car, then I have to pass the text over here. And here is the thing, we are passing the position where we have to, like, write this thing. So here at this point of time, I have randomly passed this thing, like it is going to be 100 pixel in x direction, and negative 10 pixels in y direction. And these are some, like, which font you have to write this thing. So we are using Arshis simplex font in this, and we are using it in black. So this 255 is showing black color. So I'm going to run this thing. You can see we have car here. It write car for me on this image. Yeah, so if I want to change the direction of this car, like I want this car or not here, I want this car at the top of left corner, then what we are going to do is we don't going to change the value of x, but we are going to change the value of y. I'm going to less 500 pixel from this, and this my wire structure. This is basically internet. And yeah, you can see the car is here now. So you can clearly use this pixels and one thing to get the location where you want to write these things. So that's how you enter this. I want this and that's what I write. 400 here 20. So see, the car is now at the top right corner, top left corner. Sorry. So that's how we are going to use different OpenCV functions to process, like, to play with the images. Like you would want to write anything, you want to blur anything, you want to read it in RGB scale format, or you want to read it in grayscale format. All that thing you can play with this OpenCV library. You can explore. There are multiple functions that are available in the OpenCV documentation. You can export that documentation and read all that thing according to your need and like
Sir,
according to the
in the
projects.
application, the bottom left, the values of X and Y were different. So how were
What?
you deciding? So the window that you opened, OpenCV window, I am so
Okay, this one.
the another window when you run this code.
Okay, yeah, this.
So the position of the car, the
Hmm.
coordinates are different than what we wrote. So how are you deciding the
So
coordinates?
so wait, the coordinates are not different. So see, this is the value of x. So x is like horizontal coordinates. This is x, this is y. So the value of x is 20. So see, it is going to calculate 20 pixels from this line, the starting of the left side. It is going to like gap the 20 pixel, and then from there it is going to write the car. And for y coordinates, what I have done is I have taken the shape of this image, like this whole shape, this whole
Yeah.
shape,
Hmm.
and I have subtracted 400 from that. So let me do one thing. I'm going to take this thing. Wait for a minute. I'm going to write 20 pixel over here. So what it is going to do is it is going to give, see, now it is at the top left corner. Give me one here, 50 pixel. See, now it is here. So you have to like measure way from where you have to start to write this thing from x to right, yeah, like x to y direction. That's how you can like in going ahead. What we are going to do is we are going to automate this thing. Like the program is going to calculate the value of x and y according to the objects that we are going to do in later in this project.
Okay.
Okay. Anyone have any doubt? Anyone? You can unmute yourself. Anyone else? Okay. So going ahead, what we are going to do is this thing you can explore by yourself. Like we are going to see the documentation of OpenCV library whenever we need, because no one can remember all the functions that are there in the documentation. We are going to go with the documentation whenever we need. We are going to take care with of the documentation, and yeah, we can use that going ahead. So this is the computer vision library, how we can use it, and for our use cases we can use different functions of computer vision to like process the images. And yeah, we are going to do the object detection now. Wait for a minute, I will take your attendance and then we are go ahead. Screen available, like is my screen visible to you?
No, sir.
No. Yeah, now it is visible.
No, sir.
No.
No, sir.
Okay, so what I'm going to do is I'm going to speak the name of yours, and you can mark yourself present or absent, right? Priyanshu Singh Chauhan, is he present?
Present, sir.
Okay. Hemesh Verma,
Present, sir.
Kurisai Mihita, Janani P,
Present, sir.
Somyajit Khan,
Present, sir.
R.K. Sharma,
Present, sir.
Vaibhav Bari,
Present, sir.
Shraddha Sagar Patil,
Present, sir.
Nagarjun,
Present, sir.
Anchal Sati,
Present, sir.
Pratha Saradi,
Present, sir.
Rudra Pratap Singh, Rudra Pratap Singh, Koruvada Uday Kiran,
Present, sir.
Anirudh,
Present, sir.
Atharva Khobrekar,
Present, sir.
Prashant Sharma, Prashant Sharma, Rohit Chaudhary, Rohit Chaudhary, Kavita Thakur, Kavita Thakur, is he present? Kavita Thakur? No. Okay. Kabir Mittal, Kabir Mittal, Arya Falke,
Present, sir.
Balam Sainitha,
Present, sir.
Bhumika Samal, Bhumika Samal.
Present, sir. Present,
Okay.
sir.
Arman Sharma.
Present, sir.
Okay. Now my screen is visible to you, right? Okay. So we are going to start with like the basics of object detection, like how we can download the YOLO model, how we can use the YOLO model, and all that thing. I am going to give you a short introduction to the Ultralytics, that is YOLO library that we have to install, and you can install it using like pip install Ultralytics. And what I have done is I have imported the YOLO from Ultralytics package. I'm going to run that, and at this like for this demo what I have used the YOLO V8 model. So I have like imported the YOLO V8 model in this thing, and to predict like what items are there on the images, what we have done is we can do like a model dot predict. So what it is going to do is it is going to from this image wait for from this image what it is going to do is it is going to detect every object that is there in this model. Like we are having one car over here, so it is going to detect this car, this car, this car. It is also going to detect the persons that is there in this. See, you can see there is a person in this taxi, so that is going to detect that person as well. There are here are multiple persons that model is going to detect this thing as well. So for our system we don't need the like if there are multiple person we don't need the data of that persons. We just need the cars and the vehicles that are there and the number plates of that vehicle. So for this purpose what we are going to do is we are going to fine tune this model to detect multiple objects that we need, and then we are going to filter that thing. And going ahead what we are going to do is we are going to like I have predicted the results and printed the results. So in results you can see is the first object that it is going to it is detecting is a person. It is detected the second a bicycle. Third one is a car, motorcycle, airplane, bus, train, truck. So it is also detecting the train as well. So we don't have any train in this. So yeah, that's the main purpose. So we have to fine tune this model for our use case. So we are going to fine tune this for detecting truck, bus, car, and all that thing. So yeah, this is the number. This is the object that is it is detected. This is the coordinates of that objects, like x and y coordinate of all the objects is that it is detected. So see here. See, these all are objects, and these all are its coordinates, like x and y coordinates that it is detected from this image. Yeah, so it is detected this thing. Now what we are going to do is we are going to mark that objects with this library called PIL. So that library is specifically for processing the images, and if you want to write anything on that image, you can use the PIL library. You can explore its documentation from Google. So what I've done is I've imported image from PIL library, and I'm going to use this array, the coordinates of the objects. I'm going to pass this array into the from array function. I have passed the result dot plot, and these are the values that we have to pass in case we want to like mark this thing. See, so what it is done is you can see it is detected multiple objects in this thing. It is detected a person over here from his head. It is detected a car, a person in this car. Detected bus, multiple bus are detected. It has also detected the traffic lights. Here are traffic lights. It has also detected the motorcycles over here. So this value is nothing but the score of that detection, like how much percent the model is confident that it is car. So in this case, the model is 89% confidence that it is having 77% confident that this thing, the object is a motorcycle. Here you can see the model is not that much confidence about that, like it is human or a person. So it is given a less score to that detection that the model is only 29% confident that it is the person. So that's how the YOLO model works to detect the objects within the given images. So here what we are going to do is going ahead what we are going to do is we are going to filter these objects based on its confidence score. If the score is below 50%, then we are not going to consider that object in our system. So we are going to give a condition that if the value of the score is below 50%, then we are not going to consider that object in our analysis. That we are going to see going ahead. We are going to do all that thing. So yeah, for today's lecture, we are done with this. So what you have to do is I'm having some task for you. Okay, so anyone has any doubt in this? If you want to ask anything, you don't understand anything, that thing, you can unmute
That
yourself.
means in this we don't need to train the model.
Yes. So so what the thing is, YOLO is already a pre-trained model. If we want to use for our specific use cases, then we have to fine-tune the model using our own images and all that thing. So in this thing, you can see it is detecting all the objects that are there. It is detecting traffic light, bus, truck, car, person, motorcycle, all the things. But in our use case, what we want is it is going to only detect the vehicles that are there. We don't want to detect the traffic light. We don't want this persons and all that thing. So for this purpose, we are going to fine tune with the YOLO model going ahead. Yeah, anyone?
Sir, you will send the data set or we have to download
What?
about the data set.
So we have to find the data set from Google. We are going to find that data set, and then using that data set, we are going to fine tune this model.
Like which data set, sir?
We have to find the data set from Google. I don't have any data set at this point of time. We can find the data set from any library from Google or Python. Then we are going to fine tune it with that data set. Yeah. Anyone else?
So we are using like YOLO version 8. Isn't version 9 the latest one?
Yeah, so the thing is that some models are the stable models, like stable models that we can fine tune for. Yeah, we can use your YOLO V8 as well, V10 as well. But the YOLO V8 is the stable version for fine tuning. That's why we are using that YOLO V8.
Okay.
Yes. Yeah. Anyone else? If you don't understand anything or you have a doubt, you can ask. Anyone? Okay. So today's your task is you have to go through the documentation. You can search OpenCV documentation. You have to go through this like we have multiple methods and other thing. You can explore this thing and find the methods that are useful in our use case. You have to go through this. You have to go through this by the tomorrow's lecture. And in tomorrow's lecture, what we are going to do is we are going to dive deeper in this YOLO model and how we can like fine tune all that thing and how we can use for our own purpose. We are going to see this thing deeply in next lecture. Till then, you can explore this OpenCV library and YOLO documentation for your reference. Yeah. So done for today's lecture. If anyone has any doubt, you can ask, or else we can end this meeting. Anyone is in doubt?
Please share the code with us, sir.
Yeah, I will going to mail you the share like this notebook and the image that I have used. I'm going to share that thing with you. Yeah. Anything else? Okay. Yeah. Thank you guys for joining. See you tomorrow. Yeah.
Thank you, sir.
Bye.
Thank you, sir.
Yeah. Thank you. Bye.